Welcome to the NJIT website and math podcast. My name is Vanessa, and today I'll be covering quadratic functions. So I'm going to cover a long list of things that you can do with quadratic functions. First, I'm going to go over what they are, how they look like, and their standard form. Then I'm going to go over briefly an example of how to get the equation of a quadratic function using given a couple of points on a graph. And then finally, the biggest part of this tutorial is how to graph a quadratic function, both from the regular form and how to convert it into standard form and then graph it. So let's get right into it. A quadratic function is simply just a polynomial function where the highest degree of the variable is 2. And that's where you get the name quadratic for the high degree of 2. So one of the forms that you may see the quadratic function is such. F of x is equal to ax squared plus bx plus c. And that's where we get the quadratic name is from the x squared, where the highest degree of the polynomial is 2. And granted that the one stipulation is that a cannot equal 0, because then that would cancel out the first term, and then you would just have a linear equation. So this is what constitutes a quadratic function. Now, it's important to know what they look like on a graph. Quadratic function takes the shape of what's called a parabola on the graph. So if we were to draw a graph real quick right here, a parabola would simply look something like this. And now, depending on the a term, determines whether it faces up or it faces down. If, in this case, in this example that I showed you, if a is greater than 0, it faces up. If a is less than 0, or negative, it faces down, like so. And now the magnitude of the a value also determines how wide it is. The smaller the a value, the wider it gets. In other words, say if a were be equal to 2, it would take this shape right here. Now, the smaller you go, the bigger it gets. So, if say we made a 1, it would actually be wider, like so. And if you went into fractions, like say making a equal to 1/2, it would be even wider. Okay, and the same goes for the negative. If it's negative, we'll call this, say if this was negative a equal to negative 1. Now say if we went bigger, say if a was negative 2, it would actually go smaller, right? Or more narrow. I know it's a little bit contradictory than what we would expect, so you have to keep thinking to yourself, the bigger the a value, the more narrow your parabola is, and vice versa. So the next topic is what's known as expressing the quadratic function in standard form. Now the form that we previously saw, which was the ax squared plus bx plus c, that's one of the forms that we typically see in an equation. However, what's known as standard form is a different version of the quadratic function, which allows us to simply pluck out all of the elements that we need to graph it. And it's expressed in this form. Call it f of x is equal to a x minus h squared plus k. This is what's known as standard form. And please keep in mind that the variable that we're using is x, and all the other letters represent numbers. So A, as we previously discussed, that describes how wide or narrow the parabola is, and also if it opens face up or face down. Again, the bigger the A, the more narrow your parabola is, and if it's positive A, it faces up. If it's negative A, it faces down. Now, and then the other two numbers that we need to use are the h and the k. The h and the k can be plucked out and written in this form, h comma k, because they represent the vertex of your parabola. Basically, your mid-center point. So, if you draw it out real quick, if you have a parabola as such, your HK is right here. And from there, you can pretty much graph very simply your parabola. So let's take a point. So let's say you had you didn't have the function in standard form. What if you just had 2 points? How would you graph it? Well, let's do an example of such. Now, an imperative point that you do need is the vertex. So, in an example, say we were given the vertex point as -3, 4, and you're given an additional point that which the parabola passes through, and your additional point is -4, 7. And from this, you want to transform it into our standard form, because standard form is the way that we're going to be able to graph it. Okay, so first thing you want to do is you want to write out the standard form in its variable state, which is a x minus h squared plus k. Alright, now we know for a fact that the h and the k are the vertex of your equation. So we're going to use the first point. So we're just going to replace it. And then also in the additional point, which is -4, 7, is just any point on the parabola, so you can pretty much replace this for y and x. And then this will be h, k. So all we're going to do is take those 2 points and we're going to fill them into the equation. X and y and h and k. So if we do that, we know our y is 7 equals, we don't know a yet, that we have to get still, but we know x in this case is -4, minus h, which is a -3, so here we have a double negative, so please be aware of that, squared, plus k, and k here in this case is 4. So let's simplify this a little bit. We have 7a, and then we have -4 minus -3, which is the same as +3, squared, plus 4. Okay, now if we simplify the right-hand side of the equation, we get 7 is equal to a minus 4 plus 3 is a -1. -1 squared is +1. Okay, plus 4. Then from here, we just simply want to solve for a. So in order to solve for a, we're going to subtract 4 from both sides. And then that cancels this out. And this just simply gives us 3 is equal to a. So now we have a. So now we're going to go back to our original form with the variables, and all we're going to do now is to get our final answer is we're going to plug in for a, we're going to plug in for h, and we're going to plug in for k. So then our final answer is simply going to be y is equal to 3, because a came out to be 3, and then x minus negative 3, which is going to be x plus 3, right, squared, and then plus k, which was plus 4. So this is our final answer of our quadratic function in standard form. Now, what if you were given the a quadratic function, but in the original form that we first talked about, ax squared plus bx plus c, but you wanted to convert it into standard form so that you could graph it? Well, that's a pretty easy process, so let's go over an example of that. So say we had a function f of x is equal to minus 2x squared, oops, plus 8x minus 5. Okay, so now the easy way of doing this is just simply by completing the square. Now if you don't remember completing the square, we do have another tutorial that goes over that, so you might want to refer back to it. So let's do that. Now as you remember that the first variable, in this case being the x squared, has to have a variable of 1. I mean a coefficient of 1. So we need to divide everything by 2, or negative 2 in this case. So if we do that, we get x squared and then if you divide 8 divided by negative 2, that gives us minus 4x, and then negative 5 divided by negative 2 is a positive 5 over 2. Okay, so then as you remember, we have to complete the square by taking the second term, which in this case the coefficient, which is negative 4, we're going to divide by 2 and square it. So don't forget, we have to rewrite here minus 4x. We leave a gap, and then write 5 plus 5 over 2. Okay, so if we take our negative 4, divide by 2, which is negative 2, negative 2 squared is a positive 4. Positive 4, and don't forget, we have to cancel it out by doing a minus 4 over here. Okay, then what you do is you take the first 3 terms, you group them together, and then those first three terms have to be condensed using perfect binomial square. Binomial square in this case would be x plus 2 squared. I'm sorry, x minus 2 squared. Don't forget, it's the square of the perfect square of the first term, the third term, and then you take the sign of the middle term. In this case, it was a negative 4. So that's why it's x minus 2 squared, and then you add 5, and then you just add whatever's left over. 5 halves minus 4, which we can convert into a common denominator, 5 over 2, minus a 4 in halves, which would be 8 over 2, and then just subtract across. 5 minus 8, which is negative 3. So our final answer, which is f of x, is equal to x minus 2 squared minus 3 over 2. And that's exactly in standard form. X minus h squared plus k. So then from here, we can actually graph it, which is going to be our next example. So whenever you want to graph a quadratic function, your first step is to convert it into standard form. If it's already in standard form, you're set with the first step, But if it's not in standard form and it's given to you in the ax squared plus bx plus c form, now you just have to do completing the square in order to get it into the proper standard form. Once you do that, then you're ready to start graphing. So we're going to do another example so we can get some practice in graphing. Okay, so say we had this function. F of x is equal to minus 3 x plus 2 squared plus 12. Okay, this is already in standard form, so we're through with the first step. Now our next step in this case is we have to identify A, H, and K. Now if you recall from the previous example, A, it determines the shape and how wide the parabola is, and then H and K are of course our vertex. So in this case, A is minus 3, which means that the parabola opens down, and then we have 2 and 12. So that means our vertex, so we have h equal to minus 2, because don't forget our standard form is x minus h, which means that this is actually x minus minus 2. So our h is actually minus 2, and then our k is equal to 12. So we have our shape and we have our vertex. That would be the first step. And then the next step is we need to get our intercepts. Our x and our y intercept, if you don't recall, is the x-intercept would be where the parabola crosses the y-axis, and the y-intercept is where it crosses the x-axis. So if we have those points, those are just some extra points so that our parabola can be more accurate. So first let's get the x-intercepts. So what we need to do is to get the x-intercept is we need to make y equal to 0. So if we do that, f of x is also represented by y in this case. So we need to make the left side of the equation equal to 0. So if we do that, we get 0 is equal to minus 3 x plus 2 squared plus 12. Okay, so first thing we want to do is we can move the 12 over to the other side of the equation. So we're going to subtract 12. Subtract 12. So that gives us a minus 12 is equal to minus 3 x plus 2 squared. We're going to divide both sides by 3, or by negative 3. That gives us a positive 4 is equal to x plus 2 squared. Now we want to get rid of that squared, and if you recall with radicals, the way to get rid of a square is by taking the square root. So we're going to take the square root of both sides, and that gives us plus or minus 2, because don't forget, when you take the square root of a number, it's both the positive and the negative, is equal to x plus 2. And we're going to move that 2 to the other side by subtracting it. So minus 2, minus 2. Okay, so we are left with two answers. It's going to be a positive 2 minus 2, which just gives us 0. And a negative 2 minus 2, which also gives us negative 4. So we have two x-intercepts. That means that the parabola crosses the y-axis at x equals 0. And, I'm sorry, it crosses the x-axis at x equals 0 and at x equals negative 4. So now we have to do the same thing, but for the y-intercept, which is where we set x equal to 0. So if we do that, we get y is equal to minus 3, and here we have an x, so we make it 0, x plus 2 squared plus 12. And let's simplify. Y is equal to 0 plus 2 is 2, 2 squared is 4, so we have negative 3 times 4 plus 12. Then we simply have y is equal to negative 12 plus 12. Y is equal to 0. So there's our y-intercept. Our y-intercept, which means that the parabola crosses the y-axis at y equals 0. So then, of course, when you get the x-intercept and the y-intercept, you have to get their corresponding coordinates, because of course a coordinate is made up of both an x and a y-intercept. So if you do that, which you do by simply plugging in our y-intercept, if you were to plug 0 in for y, you'd get 0. So our y-intercept is 0, 0. And then I'll write up here in the corner, if you were to plug in x 0 and x for negative 4, I'll actually write them here. This is also 0, 0. And then this would be negative 4, 0. Correct? So actually 0, 0, which is the origin of the parabola, it acts as both an x-intercept and a y-intercept because the parabola crosses through the origin. And the origin is naturally a part of both axes. So now we have everything we need to graph the parabola. So let's do it. Okay, I'm going to draw big. Okay. And it's good for practice as you go along to label points. So, if we recall back, the first thing you want to do is you want to graph your vertex. That's the best starting point. So, and our vertex was negative 2, 12. So negative 2, and I'm just going to make 12 up here somewhere. So that is negative 2, 12. That is our vertex. I'll put a little v for vertex. Okay, next step is you want to graph your intercepts. So our first intercept was 0, 0, which was both our one of our x-intercepts and our y-intercept. And then the other intercept was negative 4, 0, which is about here. So I just want to label it negative 4, 0. Okay, and the last step is just to connect the dots. So you remember from our a value was negative 3, which means that the parabola faces downward. So just go from your parabola, that's one side, and then do the same thing on the other side. And it faces down, which makes sense. If something were to happen where you would draw all your points, and when you connect those points, it forces your parabola to face up, then it means you probably did something wrong in your graphing, or in your calculations as well. So that's always a good check. And that is how you graph a quadratic function. So thank you for visiting the NJIT website. If you need any further assistance, please stop by the CAPE or the Center for Academic and Professional Enrichment, located in Kupfrian Hall, room 200. Good luck in your studies.